Welcome to the channel. Today, we're going to explore two of the most important methods for dating volcanic rocks and ancient geological remains: Potassium-Argon dating and its improved version, Argon-Argon dating. These methods have been essential for understanding the Earth's history and the evolution of life. Join us to discover how they work, how reliable they are, and their limitations. Potassium-Argon dating is a radiometric dating method used to determine the age of volcanic rocks. It is based on the radioactive decay of potassium-40, an unstable isotope found naturally in various minerals, into argon-40. This process occurs because potassium-40 decays into argon-40 over time, in a process that has a half-life of approximately 1.25 billion years. Argon-40 is an inert gas that, when formed in rocks, is trapped in its crystalline structure, allowing us to calculate how much time has passed since the rock solidified. This method is especially useful for dating volcanic rocks that are between 100,000 and over a billion years old. Although potassium-argon dating has been widely used, in the 1970s, scientists developed a more accurate and efficient version, Argon-Argon dating. In this method, instead of directly measuring the proportions of potassium-40 and argon-40, potassium-39, a non-radioactive isotope, is converted into argon-39 by irradiation in a nuclear reactor. Then, the ratio of argon-39 to argon-40 is measured, which provides a more accurate measurement with less margin of error. The advantage of the Argon-Argon method is that it can be applied to much smaller samples, which reduces limitations on sample size and allows multiple measurements on the same rock, increasing accuracy and error control. Section 3. Applications of Potassium-Argon and Argon-Argon dating. Both Potassium-Argon and Argon-Argon dating are essential tools for geologists and archaeologists. These techniques are mainly applied in dating igneous rocks, such as basalts, granites, and other volcanic formations. They have also been crucial in dating ancient volcanic eruptions, which allows us to track volcanic activity throughout Earth's history. Fossil dating, since the layers of volcanic ash found at archaeological or paleontological sites can be dated with these methods, helping to establish accurate chronologies. These methods have been vital to understanding the planet's geological history, helping scientists determine the age of key events in the evolution of Earth and life. Section 4. Reliability of the Potassium-Argon and Argon-Argon methods. The reliability of these radioactive methods is high when applied under the right conditions. The extremely long half-life of potassium-40 ensures that the decay is slow enough to measure geological time. In particular, the Argon-Argon method has proven to be more accurate than the Potassium-Argon method, as it minimizes experimental errors, such as sample contamination. It allows the analysis of smaller samples, which is crucial in archaeological and paleontological research. It improves temporal resolution, as multiple measurements can be made on a single sample, averaging the results to obtain a more accurate date. One of the best-known cases of the success of these methods is the dating of fossils in the Olduvai Gorge region of Tanzania, where layers of volcanic ash have made it possible to establish reliable ages for important fossil discoveries. Section 5. Limitations of the Potassium-Argon and Argon-Argon methods. Despite their accuracy, there are limitations to both methods. Contamination. If rocks have been altered by later geological processes, such as fluid movement or reheating, argon-40 may have escaped, or argon from the environment may have been added. This can lead to an incorrect age. Applicable materials. It can only be applied to igneous rocks and not to sedimentary rocks, which limits its use. However, minerals found in sediments can often be dated if they came from volcanic eruptions. Initial equilibrium. In the Potassium-Argon method, if there is inherited argon from older sources that has not been completely removed from the rock, it may appear that the sample is older than it really is. The Argon-Argon method helps to solve this problem to some extent, but it remains a challenge in some conditions. Minimum age. These methods are not useful for dating more recent events, as accuracy begins to decrease when events occurred in the last 100,000 years or less. For these events, other methods such as carbon-14 are more appropriate. Section 6. Conclusion and final thoughts. In short, Potassium-Argon and Argon-Argon dating are robust and reliable methods for dating geological events that occurred millions of years ago. These methods have been fundamental in unraveling the mysteries of the past, allowing us to date with some accuracy events as diverse as volcanic eruptions and fossil remains that have shaped human history. However, as we have seen, Their accuracy depends on the samples being in the right conditions and the absence of contamination. Despite these limitations, they are essential tools in scientific research and continue to play a crucial role in our understanding of Earth's geological past. Thanks for watching. Don't forget to subscribe for more videos on science.